Okay, so we're going to look at converting moles to a certain amount of mass of that element. And we're going to go through different conversions in this video, so we have lots of questions to get through. The first question is, what is the mass of 3 moles of aluminium? So the first question we have to ask ourselves is, what is a mole? So a mole of any substance is 6 by 10 to the 23 atoms of that substance. So in this example, it's going to be 6 by 10 to the 23 atoms of aluminium for 1 mole. And we call that number Avogadro's constant. And it's just the exact same as saying a dozen is 12 and a baker's dozen is 13. So when we hear a mole, we need to think that it's 6 by 10 to the 23 particles or atoms of that substance. Okay, and to measure out 1 mole of anything, we look at our periodic table and we look at the relative atomic mass. So aluminium has a relative atomic mass, if you round it, to be 27. So that's 27 atomic mass units. Okay, so if 1 mole is equal to the relative atomic mass, which is 27, so 1 mole of aluminium is equal to 27 grams, then 3 moles is equal to that mass multiplied by 3. Okay, and that's going to get you the mass for 3 moles, which is 81 grams. So to get 3 moles of aluminium, you have to weigh out 81 grams. I also just want to bring your attention here that to measure 1 mole of any substance in the red, use the relative atomic mass. So you see how this is just aluminium? We're going to use the relative atomic mass. In the next question, we're going to use the relative molecular mass. And that's just a differentiation between an element and a molecule. It could also be called the molar mass or the particle mass, because we know that in molecules we don't have ions. So that's leaving out our ionic substances. So it can come under different names, but you'll get the hang of it after a while. So moving on to the next question. What is the molecular mass of water? So we're going to use molecular mass because it's not just a single element, it's a molecule. So water is H2O. It has 2 atoms of hydrogen, so we need to take that into account. Each hydrogen has 1 atomic mass unit, and the oxygen has an relative atomic mass of 16. So we have 2 H's and 1 oxygen. So all of that together would weigh 18 grams. Okay, so 1 mole of H2O would be 18 grams. Okay. The next one, what is the mass of 1 mole of our sulfate ion? So we have 2 minus signs there. The minus signs represent that our sulfate usually takes on 2 electrons. It's gained 2 pieces of negativity with a negative charge. But compared to protons and neutrons, electrons are extremely light, so we don't need to take the minuses or pluses into account at all. Most of our mass comes from the protons and neutrons in a molecule or in an atom. So we can just focus on the elements again. So we have 1 S and we have 4 oxygens. So 1 molecule of this is going to take in the mass of 1 sulfur and 4 oxygens. Okay, so 1 mole is equal to the relative molecular mass. So it is a molecule. Or that should be particle. Okay, it's an ion. So we're going to say the relative, and we're just going to say molar mass to get 1 mole. So count up everything. We have 1 atom, that will be 32 atomic mass units, and we have 4 oxygens of 16 atomic mass units each. So if you do up that sum, we will get a relative molar mass of 96 grams. So 1 mole of that ion will be 96 grams in weight. Okay. How many moles? Now we're going from mass back to moles. So we have a certain mass of these substances, and we need to figure out how many moles are in it. So we have a little equation here. The mass that's weighed out is on top. The relative atomic or molecular mass or molar mass, to include our ionic compounds, equals the number of moles. So you're going to see how many times does 1 mole basically go into the mass that you've weighed out. So in the question we have 36 grams of carbon. So I'm going to follow my formula. 36 grams is what I have weighed out. The relative atomic mass is 12. So 36 divided by 12 will get you the amount of moles in that amount of carbon. So we'll get 3 moles. Okay, now why don't you try and pause the video and do this next one for hydrochloric acid. So take note of your formula and work your way through it. Okay, so hopefully you've tried that now. So how many moles are in 12.25 grams of hydrochloric acid? So we have 12.25 grams weighed out. That's going to be on top of our line. But what's the relative molecular mass of that? What would 1 mole of H2SO4 weigh? So that's what we need to figure out. So we have 2 hydrogens, 1 sulfur, and 4 oxygens. Okay. So each hydrogen has 1 atomic unit. Each sulfur has 32. And we have 4 oxygens with 16 each. So as a molecule, this will have, let's do the little bit of calculations here. .98 atomic mass units. Okay, and if we want to just convert that to 1 mole, that's 98 grams. So 1 mole of H2SO4 is going to weigh 98 grams. So now let's use our formula. The actual mass that we have is 12.25, and 1 mole would be 98 grams. So we can see that we're going to get less than 1 mole. We will get 0.125 moles of H2SO4. Okay? Now, How many molecules are in 1.5 moles of water? So in red, we've got a little reminder there of what we talked about at the start. 1 mole is 6 by 10 to the 23 atoms or particles. And that relates to molecules as well. So think about, what do we need to do? Do we need to look at our relative molecular masses here? Or is there a quicker way to find out how many particles or how many molecules are in that much moles of water? Okay, so if 1 mole equals 6 by 10 to the 23, 1.5 moles, we just need to multiply that number by 1.5. Okay, so you're multiplying each side by 1.5. Okay, and once you've done that, 1.5 moles of water contains 9 by 10 to the 23 molecules. Okay, so it didn't even matter that it was water. 1 mole of any substance is always going to have 6 by 10 to the 23 particles. Always. Okay, so grams to number of particles. So in this question, we're asked, how many molecules of carbon dioxide are there in 150 grams of carbon dioxide? So why don't you pause the video here again and just give it a go. Okay, so we do have a weight. We're given 150 grams. And I have my relative atomic masses over there. So I can find out the relative molecular mass of carbon dioxide. So let's do that. We have 1 carbon and 2 oxygens. So altogether, 1 molecule of CO2 will give us 44 atomic mass units. And if we want to convert that to 1 mole of CO2, we'd have 44 grams. Okay, so let's go back to our old formula. Mass over the relative atomic mass or relative molecular mass gives me the moles. So I have 150, and we want to divide that by what we've just worked out, which is 44. Okay, so 150 divided by 44 is 3.4 moles. Okay, so I have that many moles. So it says how many molecules of CO2 are there? Well, each mole contains 6 by 10 to the 23 particles, molecules, or atoms, depending on the type of substance you're looking at. So here we have 6 by 10 to the 23 molecules. So 3.4 moles will be 6 by 10 to the 23 times 3.4. Which will give you 2.0 by 10 to the 24 molecules. Okay, now, how many moles are in 9 by 10 to the 22 atoms of aluminium? So think about it. Do I even need to know that it's aluminium? I know that 1 mole equals this. And it's atoms in this case because it's pure aluminium. So I can just do it as a fraction. 9 by 10 to the 22 over 6 by 10 to the 23. And that'll give me how much I am in relation to 1 mole. So 9 by 10 to the 22 by 6 times 3, 0.15 moles of aluminium. Okay, so why don't you pause again and give a go to this one. You have 3 by 10 to the 20 atoms of zinc. What mass of zinc do I have? Okay, so again, you're given atoms, so let's write that as a fraction over what 1 mole would definitely be. And we will get 5 by 10 to the minus 4 moles. Or you could write that as 0.0005 moles of zinc. So we've got that far. What mass of zinc do I have? Well, 1 mole, you look at your relative atomic mass, would weigh 65 grams. Okay, and remember our formula, mass over relative atomic mass equals the number of moles. So let's fill that in. We don't have the actual mass that we want. We do have the relative atomic mass, 65, and we have the number of moles that I have. Okay, so the mass would then equal the number of moles times our relative atomic mass. Okay, and that's the mass of zinc that we have weighed out. Okay, something slightly different. So we have a compound that we can see here. And it's asking us how many moles of our PO4 3- ions are in 2 moles of this substance. So you've seen I've written out a ratio. So let's just break it down to 1 molecule of that substance. In that molecule, we have 3 calcium ions and 2 phosphate ions. So that ratio is that 3 calcium ions come together and match up and balance the charges with 2 phosphate ions. So it's saying how many moles of PO4 3-, the phosphate ions, are in 2 moles of this compound. Well, you can say if 2 ions, or 2 particles even, are present, and that mixes with 3 particles, then if we brought that up to a mole, like let's say 1 mole of that compound, we would need 2 moles of our phosphate ions and 3 moles of our calcium ions to make 1 mole of our compound. Okay, because that's the ratio. In a 1 molecule, let's say, or compound, so 1 section, we have 3 calcium ions and 2 phosphate ions for 1 particle. okay, or one ionic, like let's say one ionic part because it comes in a unit cell. Okay, so one ionic part, let's say. One pairing. Then if I want to bring that up to a mole, you just need to continue on. So that's for 1 mole. I need 2 moles of our phosphate ions for 1 mole. Now it's not asking us for 1 mole, it's asking us for 2 moles. So if I said I need 2 moles of this substance to make a 1 mole of calcium phosphate, then I just follow along and I say, well then if I want to make 2 moles of it, I need 4 moles of that ion.